All right, good afternoon, guys. This is going to be the first video for the Unit 3 practice test. I'm just going to jump on in. I do want you to pay attention to this note at the top that tells you what all is going to be on the real test. Remember, this is kind of a carbon copy. Like, we take the same problems. We try to put the harder problems on the practice test and the easier problems on the real test. It's the same thing, different numbers. Your real test will have 5 multiple choice questions from previous units. That is not on the practice test. It's from previous units. It's from 8th grade. It's some basic math stuff that we should be comfortable doing. So I'm not going to review that. I'm going to review the stuff that's strictly from Unit 3. Unit 3 is worth more points anyway, so I'm not too worried about those 5. The constructed response is worth 11 points each, so I'll definitely probably do the constructed response in a separate video. I'm not sure how many videos this is going to end up being. I know the previous 2 unit tests, I've done it in 3 videos, so we'll see if I can. It'll probably be about the same. So let's just go ahead and jump in. So number 1, we're going to graph the solutions to the linear inequality y is greater than, not less than, y is greater than 4x minus 2. So first thing we want to do is look at our y-intercept, which is -2, and we'll put a point on that, or we'll mark that point. Alright, so then we use our slope, and that tells us how to continue our graph. So my slope is 4, which means from this point, I'm going to go up 4 units and to the right 1 unit. So up 1, 2, 3, 4, right 1. Okay, and then if I continue to go down, 1, 2, 3, 4, left 1. And that should just extend my line. Okay, so I was about to connect all my dots, but then you have to remember that it's not an equation, it is an inequality. So this is a greater than symbol. It's not greater than or equal to, which means we need to not have a solid line, but a dashed line here. So I'll take my handy dandy personal straight edge and dash my line, put arrows on it, and then since I'm going for all the solutions to this inequality, this is everything, y is everything greater than this line, which means I need to shade above that line. So I'm going to put my pencil on the line and draw a line up so I know which direction to shade in, and I'll just shade everything above that line. Okay, let me get it nice and pretty. There we go. All right, number 2, kind of the opposite. So number 1 we graphed. Number 2, we have a graph we're writing the inequality. All right, so if I look at this, we're going to figure out the y-intercept first, which is 3. Then I'm going to find my slope, which I have another point at 1, 5, so my slope is 2. So normally I would do y equals mx plus b, so that would be y equals my slope, which is 2x, plus my y-intercept, 3. And then I need to determine what symbol I'm going to use. So if I look, here's my line. I've shaded below it, so y is less than my line. And then I need to tell whether or not to put an equal to bar there. And that's determined on if my line is a solid line or a dashed or dotted line. And it's very hard to tell, but looking at it, it is a dotted line. Like, I had to actually scrunch my face up real close to it. So it is a dotted line, which means it's not equal to. So this would be our final answer. All right, number 3. Tell whether this ordered pair is a solution of the system. So if this ordered pair is a solution to the system of equations, that means I could plug this in for x and this in for y into both equations, and it would be a true statement. So let's do that. I'm going to use 2 colors so that you can tell I'm plugging things in. So my first equation is 2x minus 2y equals negative 12. So x is negative 2 here, and y is 4. All right, and we'll simplify this. So 2 times negative 2 is negative 4. Negative 2 times 4 is negative 8. Negative 4 and negative 8 is negative 12. And negative 12 is equal to negative 12. So it is a solution to the first equation. A lot of people are going to stop here and be like, boom, it's a solution. But we have to check both. If it's a solution to one but not the other, then it's not a solution to the system. So let's do the same thing. We'll plug in our x values and our y values and see if it makes a true statement. So x is negative 2, y is positive 4. Negative 2 times negative 2 is 4. 3 times 4 is 12. 4 plus 12 does in fact equal 16. So this is a true statement. So yes, negative 2, 4 is a solution to the system. All right, number 4, solve the system by graphing. So we are going to graph both of these equations on the same coordinate grid, and we will find their intersection point, and that will be the solution to the system. So pretty much just using rise over run, using slope and your y-intercept to graph it. So we'll graph this first one in brown. My y-intercept is 7, so we'll put a point on 7. And my slope is negative 1. So if you don't see a number in front of the x, that means it's a 1. So my slope is negative 1, which means I'm going to go down 1 and over 1. And down 1 and over 1. Should be like a perfect diagonal line. Okay. And then we'll connect all the dots. Since this is an equation, we don't have to worry about shading or anything. It's just, oops. It's just a line. Okay, the second one I will graph in green. And this is, it has a y-intercept of 5, so I'll put my point on 5. And a slope of negative 2/3. So that means I'm going to go down 2 and right 3. Down 2 and right 3. Down 2 and right 3. Uh-oh. Wait, 2, 1, 2. Let me double check this real quick. Let me make sure I didn't make a silly mistake. It's not going to. Oh goodness, the solution's not on the grid. All right, I'm going to pause this. I'm going to double check everything, and you won't notice a difference because I'll just pick the recording back up. Okay, I figured it out. Miss Gallant can't count. I started my graph at 9, not 7. So if I graph that correctly and started at 7, and then go down 1 over 1. Oh, that's so much nicer. Oh, that's so much nicer. Okay, so then we can actually find an intersection point. My bad, guys. Math teachers make just as many mistakes, if not more than y'all do. Alright, so I have a point right here at 6, 1. So there's the solution to my system. Alright, number 5. Okay, so yeah, the solution to number 4 is 6, 1. It's where the pink and the green line intersect. Just ignore that brown line. All right, number 5. The Fun Guys game rental store charges an annual fee of $10 plus $5.50 per game rented. or per game. For how many game rentals? Oh, wait, no, I'm reading this wrong. Okay, all right. The game bank charges an annual fee of $28 plus $2.50 per game. For how many game rentals will the cost be the same at both stores? And what is that cost? So we have two different companies. We have the Fun Guys and the Game Bank. And they both charge an annual fee for their membership, as well as a rental fee per game. So Fun Guys, we'll do a y equals for their equation. Fun Guys, we have y equals, so they charge an annual fee of $10 and then $5.50 per game. And since it's per game, we know that that's our slope. That's going to be based off of the number of games. So we'll have a variable there. We'll put x there. Our other equation, the one for Game Bank, is going to be this. We're going to say it the same way, $28, and then their cost per rental is $2.50. So we'll add it like that. Okay, so we have a couple of different ways to solve this. If you remember, you've got 3 different methods for solving equations. You can graph them like we did on number 4. You can use substitution, or you can use elimination. This one, if you have a coordinate grid, it's an easy one to graph, but it's also, because they're both set as y equals, it's easy to use substitution, which means since y is equal to 10 plus 550x, I can replace the other y with 10 plus 550x. So we'll replace y with this expression. So I've got 10 plus 550x equals 28 plus 250x. Okay, and I'm going to need to solve for x and get it by itself. So I think that it's much easier if you move the smaller x over. So we're going to subtract $2.50 from each, or $2.50x from each side. That cancels. This will be 10 plus 3x equals 28. We'll subtract 10 from each side. Again, we're trying to isolate this x. It's going to give me $3 times x is equal to 28 minus 10 is 18. Divide both by 3, and x is equal to 6. Okay, so x, we have to remember, is the number of video games, not the cost. So how many game rentals will the cost be the same at both stores? That's going to be for 6 games, and then we need to see how much that cost is. So I'm going to plug this back into either one of these two equations and solve for y. So we'll plug 6 in. It doesn't matter which equation you go with. We'll plug it into this bottom one. And so y is going to equal 28 plus 250x. But instead of x, we're plugging in 6. Okay. So we're going to do 250 times 6. And that's going to give me 15. So I have 28 plus 15. And that's a grand total of 43. So what that means is for 6 games, the cost is $43. And that's at both locations. All right, number 6. We're going to solve this other system by graphing. So, and I'll make sure I graph it correctly this time. Okay, so y is equal to x minus 1. So my y-intercept is -1. And since there's nothing in front of x, that means my slope is 1. So that means I'm going to go up 1 and over 1 unit. or up one and right one. And then to continue it, down one and left one. Okay. And then I'm going to use my straight edge. Had to find it. I moved it out of the way. So I'm going to use my straight edge here. Put my arrows on so I know it continues on forever. And then we're going to graph this. So we're going to start at positive 9. And my slope is negative 3 over 2. So I'm going to go down 3 units and right 2 units. Down 3 and right 2. A lot of students ask me, why do I not go down and left? Well, down is a negative direction and left is a negative direction. And if you remember, 2 negatives is equivalent to a positive. So if I go down and left, well, then my line will have a positive slope like this one. If I want it to have a negative slope, I gotta go down and right. Okay, we'll connect here. Okay, and so I need, for my system, I need to figure out where they intersect. And that's right here, and that's at 4, 3. Okay. All right. So, I know that's only 6 questions. I don't feel like I spent a lot of time yakking though, so that's good. I'm going to stop this video here. And so I think I'll just do a page of video, and that, you know, smaller chunks, y'all might pay more attention. We'll see. All right, so thank you for your attention. Thank you for watching this video. I hope it's helped you some, and I'll see you in class soon.